please welcome Juergen Hoeller.
Thank you. All right. Check. Yeah. All right. Good morning from my side. Good morning, everybody. Hello, everyone here in room A1, and hello, everybody on the live stream. As far as I'm aware, there is a live stream from this room. So I have the pleasure of kicking off this morning with a little bit of a forward-looking talk here. Actually, not that forward-looking anymore, as you will figure, because I'm going to give a pretty concrete roadmap. We're not far off the Spring Framework 5 GA release at all, but nevertheless, it is very much driven by a forward-looking view onto the ecosystem that we live within, onto the Java technology landscape. So it really is a combination of themes and trends that we identified as particularly important for the Spring-based ecosystem, for Spring-based application development. Many, of course, of those are very relevant for the general Java ecosystem anyway. So before we get right into the Spring Framework 5 themes, a quick state-of-the-art recap. Where are we? We released Spring Framework 4.3 last June. So this is the current production release, GA for more than half a year already. And this is particularly worth noting because we decided on doing a 4.3 release rather late. We were already preparing for 5.0, but decided to do yet another feature release in the 4 line. And our feature releases tend to be very rich. 4.1, 4.2 happen to be very rich. 4.3 is equally rich. It's almost a sort of early backport from 5.0 in a few ways. Many refinements to the annotation-based programming model and to some integration contracts and co-container contracts that could easily be backported were actually backported to 4.3. So this is stuff that probably in other open source projects you would only get in the 5.0, but we decided to backport them, to make them available early. They are already in production for more than half a year. And in particular, to make them available on a Java 6 baseline, on Java 6, 7, and 8 based environments. So this is the 4.3 release. I'm going to just give you 2 examples of what we actually did in that one. The important note in the middle here is 4.3 has an extended support life. If you're familiar with the Spring Framework way of handling maintenance releases, this is basically the 3.2 of the 4th generation. Right? It is the one with the long maintenance life at the end of the major branch. So it's going to get maintained until 2019, possibly even longer, depending on demand. So what did we actually do in this one? These are refinements. So at first glance, this looks like a standard annotation-based Spring component class, and it is. The refinement in 4.3 is the constructor, the commented out at auto-wide annotation on the constructor. As of 4.3, as an example for what we're doing here, if there is a single constructor in an otherwise annotated class, we do not insist on that constructor being annotated anymore. A very simple refinement, really, but surprisingly useful. In particular, in an annotation-based component setup where some classes might not really have annotation otherwise at all. So this feature is active if annotation-based configuration is active in the particular deployment unit, which means a lot of classes might not actually have any annotations at all anymore if all they're doing is being a delegate using some constructor dependency injection. Of course, you may still have it, and for descriptive purposes, I actually recommend having it on a class which happens to be annotated from top to bottom. Anyway, you'd rather add the descriptive auto-wide annotation, but you don't have to anymore. Another, or actually a kind of the other side of that coin, this is a configuration class in Spring. A refinement in 4.3 is that you can do what you're seeing here. Declare a non-default constructor on a configuration class. This wasn't actually possible before for technical reasons, CQLib subclassing and so forth. It wasn't really part of the design goals either. But as of 4.3, in order to wrap up this component model, we do allow for any constructor arrangement on configuration classes, just like on any other component class. Because in the Spring Component model, configuration classes actually are regular component classes with a special role. So you can have a constructor that takes an argument for a start. That's new in 4.3. And you don't have to annotate it. So the commented out auto-wired applies again here. You can annotate it, but you don't have to, which means a configuration class can accept common references through dependency injection and store them in a field, and within its factory method, its admin methods, it can grab those references and build them into components. There are many more refinements in the dependency injection space in 4.3. We have a rich object provider API, richer than object factory, to obtain instances that might be unique or not even present in a convenient way. There are many, many little refinements in the core dependency injection model. And the other area that we're touching, this is already very connected to what we're doing in 5.0, is revisiting the controller endpoint model. This is basically a state-of-the-art 4.3 MVC controller to endpoint, to handler methods. Now, look at the mapping annotations. Those are the common Spring request mapping annotations, having all sorts of attributes on the annotation. In this case, using path and method to do typical binding to a particular RESTful endpoint. Now, in 4.3, based on common requests, we introduced what we're calling composed annotations. Those are essentially convenience annotations. They used to be possible for a number of years now. In 4.3, we decided to ship a few of them out of the box. Those are basically annotations, meta-annotated with other annotations. So instead of using request mapping directly, you would use a custom, for example, it could be a custom mapping annotation, meta-annotated with request mapping, serving the same purpose, but with a different design, maybe different convenience compromises. As of 4.3, we ship a selection of those out of the box, called get mapping, post mapping, patch mapping, put mapping, and delete mapping. They can be used in the very same place, but they use a different design trade-off. They bake the HTTP request method into the name of the annotation, which means that typically you're only specifying the path. Which means if you're only specifying the path in the Java annotation model, you can use the value shortcut for annotation attributes. You don't have to specify the name of the attribute anymore. So by reducing an annotation's design to a single attribute, you actually gain quite a bit. So those can be used in place. You can build those yourself. If you want to shorten the name to add get or add post, build them yourself. They are very trivial convenience annotations, composed annotations as we call them, simple annotation type declarations with meta annotations on them. So this is the sort of stuff we're doing in 4.3. You're actually going to see a variant of this again later on. So if we backported so much to 4.3 already in terms of programming model refinements, what are we actually doing in 5? Well, 5 is, for us, a new framework generation. In particular, in terms of the technical baseline. We're raising it to Java 8+. It's the first Spring Framework generation requiring Java 8+. And Java E7+, generally speaking, so Servlet 3.1, JPA 2.1, Bean Validation 1.1, JMS 2. We have a already long ongoing story for JUnit 5. You might be aware that JUnit 5 is in development. It's currently in the milestone phase. Was actually a sponsored effort, so it's a community effort, but sponsored. Pivotal was one of the original sponsors, and we have a JUnit contributor, JUnit committer also on the Spring Framework team. So we are very actively embracing JUnit 5. Even if JUnit 5 is probably going GA a little bit later than Spring Framework 5, we're going to ship early support for JUnit 5 already. The primary focus, however, in Spring 5 is on infrastructure themes, on basically modern, present-day infrastructure coming our way. JDK 9, for example, coming this year to be picked up at the earliest possible point in the Spring Framework roadmap. The general HTTP 2 story, allowing us to build HTTP 2-enabled stacks. And this is more than Servlet 4. We're going to get to that. But it's also Servlet 4 in general. And it is JVM languages, which happen to be a good fit with the Spring programming model, A good fit, I would also argue, for an enterprise Java development mindset, or generally for a Java development mindset, appealing to common Java developers. And Kotlin turns out to be a very interesting candidate in that space. You might be aware that in Spring Framework 4, we had a pretty strong Groovy story. Groovy is a very common companion to Spring anyway. Quite a few stacks out there actually use Groovy on Spring. Even like Grails is an entire framework built on that combination. It's also a common choice for a language other than Java in combination with typical Spring application development. But Kotlin actually has a few really sweet characteristics as well. So we are supporting Kotlin next to Groovy, basically equally first class, not necessarily for identical purposes, but just giving it the same kind of love. The same kind of first-class treatment, where the framework auto-adapts, where the framework ships extensions for the language. We're going to get to that. And there's a design philosophy, or a design focus, very present-day design focus, revisiting APIs, setup conventions from a functional perspective. Functional in the sense of Java 8's functional. So like the Java util function interfaces, collection streams, making extended use of lambdas and method references beyond the obvious or beyond the points that were there already. So that's our functional focus. And we have probably the strongest investment we do in Spring Framework 5, a focus on reactive architectures. All right, so much for the overview. I'm going to give you a few selected pieces of insight into every one of those major themes. We're going to spend most time on reactive in the end, I suppose. But I don't want to let the others come short either. So, JDK 9. You've heard quite a bit about it, right? We've all heard yesterday's keynote, Mark's sessions at the conference in general. JDK 9 is a long-running effort. Many things have been said. Let me add a few specific statements, a little bit of opinion from my side. JDK 9 will be a very worthwhile upgrade, in any case. Whether you care for Jigsaw, whether you care about Jigsaw, or whether it's none of your interest, it doesn't actually matter that much. There's a lot of goodness in JDK 9. The JVM refinements, the decomposition of the JVM into smaller modules at its core, the ability to build custom JVM layouts, JShell, right, the shell, but also a lot of JVM improvements. Compact strings alone might be the reason why you're upgrading to JDK 9. Don't even recompile your application, right? Let it work against JDK 8 level, but run it on JDK 9. And you transparently get a much more efficient runtime representation of all the string arrangements in your application, provided that the encodings actually let the JVM do the optimizations. But this is actually a very, very important refinement in its own right, in terms of the memory layout of the applications that we're building, in particular for smaller deployment units, but it equally applies to larger units. The gain is enormous. Whether the gain is important is up to you, but these kinds of JVM refinements are really the main reason why we put JDK 9 onto our immediate agenda, why our audience, Spring developers around the world, tell us that JDK 9 has to be on the immediate roadmap. There are garbage collection refinements. G1 may have been around, is the default now. There's an HTTP2 enabled protocol stack, at least intended to come with JDK 9. Will probably appear in a JDK 8 upgrade as well. The final word hasn't been spoken there yet. But there are many things coming in JDK 9 that make it worth upgrading to. It's not just about Jigsaw. But Jigsaw itself, of course, is the central JDK 9 feature, the central theme in there. And the idea in Jigsaw itself is quite compelling from a quick glance, right? The general idea is that we're replacing the class path with a structured alternative, the module path, where every archive, every jar file on that module path is actually understood as a kind of unit of deployment. It's not just a zip file with a couple of classes and resources in there. The class path is completely flat. Jar files are just archives. The JVM has no understanding of structure on the class path, but it does have a very strong understanding of the structural units on the module path. This is a very interesting twist to our deployment options, but it comes at a price. And the price is basically complexity in the deployment setup initially, where many libraries are not really prepared for this, where module info descriptors cannot so easily be added to existing Javas. There's a lot of complication coming with it, and we don't have to rehash all of this. I'm just going to summarize it at take JDK9, put it onto your roadmap, upgrade to it even if you don't touch the application's code, don't touch the application's jar structure at all, stay in class path mode initially, and JDK9 with modern-day frameworks like Spring Framework 4.3 or even recent Hibernate versions, etc. If you just take the latest open source frameworks out there, you're going to have a smooth experience. Spring 4.3 and other open source libraries of its generation are generally compatible with some of JDK9's internal restrictions already, or very close to it. So by the JDK9 GA release in July, you will have an open source landscape being generally compatible with JDK9 in class path mode at least. Module paths is kind of an opt-in option where you decide to investigate what you can do with Jigsaw and modules. But that should be a second step. Initially, just upgrading class path mode and make use of JDK9's general refinements and be on the current branch of the JDK again. That alone is a reason, right? So to give you an idea of what you can currently do if you choose to investigate Jigsaw, it's about application deployment descriptors like module info Java files living in your application jars and referring to their dependencies through requires clauses. Other modules of your own deployment layout, but in particular framework modules. So what you can do right now is put Spring Framework jars or other jars onto the module path. The JDK9 is going to interpret it as an automatic module, which is basically a jar file on the module path. It's explicitly been put on the module path, but it doesn't have a module descriptor because it's not built on JDK9. So if it doesn't come with a module descriptor, the JVM infers some common characteristics from it. It builds a module name from the jar name and makes some assumptions about visibilities, like the module sees the other modules on the module path. This is actually a quite fine, practical, pragmatic compromise. If you do this against Spring Framework jars and even Hibernate at the moment, with a couple of requires clauses in your own descriptor, this can actually work fine on the module path. Just basically dump the required framework jars onto the module path, twist your own module descriptors a little. You won't get transitive dependencies. You have to list all dependencies of your frameworks explicitly, but that's not actually that big a deal. It is doable. You can get the benefits of Jigsaw in your own applications layout with a couple of considerations, a couple of constraints. You can get them right now, or at least mid-year, mid-2017, against the current generation of frameworks. We're going to document what you can do in a Spring, Hibernate, Jackson-based scenario from our side. So this is the way that we're going. Shipping explicit module descriptors at a later point of time is in consideration, but there's an important issue with the wider open source layout out there. It's the namespace. Modules have names. In a larger dependency arrangement between open source projects, there needs to be an agreement on what those names should be going forward. Deriving those names from Maven Central is the JDK's own convention, but we also need to agree that we're going to stick with those names midterm at least going forward. But it actually doesn't make as much difference as you would think it does. Your open source frameworks and libraries do not have to ship module info descriptors yet at all. Comes at a little inconvenience, but not that big a deal really, because you have to list transitive dependencies in your descriptors then. But it is doable, it is workable, you can get the benefits of Jigsaw in your application modules already, and that's the only thing that really matters. All right, let's move on to HTTP2. It's actually a connected theme, because JDK9 originally meant to do a new HTTP2 client. it actually intends to ship an ALPN stack out of the box. HTTP 2 is just a generally, truly important industry standard to consider. I mean, this is the first revision of the central communication protocol that we're using in, every day here in all our systems. It's the first revision in 20 years. HTTP 1.1 dates back to 97, even if it didn't really enter the industry before 99. But it is a 20-year-old protocol. I mean, how overdue is a revision of that protocol? So all the benefits aside, you've probably heard this before, it just is a really important protocol to enable. Let your clients talk to your server systems over HTTP 2. Make it possible. The browsers did their job in almost everywhere. There are HTTP 2-enabled client APIs, even for programmatic Java clients. A lot of it already happened. A lot of stakeholders did their job. But we're a little bit late in the Java server space. HTTP 2 enabling is a very transparent affair. I mean, it doesn't really leak through to the application much at all. The best example is Servlet 4.0, the specification, which intends to pick up HTTP 2 and requires HTTP 2 support in all Servlet 4 compliant containers. Servlet 4 doesn't actually do much in the API. It introduces a new push build API for programmatically triggering HTTP 2 pushes. It's not actually that important. I mean, pushes, the current generation of HTTP servers can do pushing based on statistics, like the client usually requests those resources one after the other, so they just start pushing the subsequent resources when the first request comes in. This can be done based on algorithmic handling. It doesn't have to be programmatic in an application's, in the application's code base. So that API is not actually as important for applications. So Servlet 4 is largely transparently requiring HTTP 2 into our stacks. Why do we wait for Servlet 4 then? We can have HTTP 2 support in the current generation of containers already. It's transparent anyway. We don't have to have a Servlet API revision for it. And this is exactly what Tomcat 8.5, Jetty 9.3, and the latest generations of Undertow, the server underneath Wildfly, are already providing. The complications are not actually in the Servlet API there. No need to wait for Servlet 4. The complications are in the protocol stack, in the SSL stack, because traditional JDK installations up until JDK 8, current day JDK 8, do not come with an ALPN-ready stack yet. There are ways of setting this up. I mean, just check Tomcat 8.5 and Jetty 9.4's or Undertow 1.4's configuration pages in order. What do you need to do in order to make this work today? It is possible, comes with a little bit of effort, right, in getting your JDK set up right. This will be more streamlined, hopefully in a future JDK 8 upgrade, definitely on JDK 9, or, well, nothing's definitive until it's released, but you get the point. So you can do this right now. We have the infrastructure out there right now. If you're on Java 8, if you have a modern-day server-side application stack running on JDK 8, on Tomcat, Jetty, or Undertow, all you need to do is upgrade to the latest generation of your HTTP server and follow its setup instructions. That's really all it takes to enable your clients to talk HTTP 2 to your service. And that's our focus at the moment in Spring Framework 4.3 and Boot 1.4, 1.5 already. So Spring Boot brings in Tomcat, Jetty, Undertow versions. This is a topic on our end already. We're not really waiting for Servlet 4 in order to be able to do this. But of course, the moment that Servlet 4.0 will be out, and it will be out later this year, towards the end of this year, we will pick it up immediately. Spring Framework-based applications will have a very, very smooth upgrade story to Servlet 4 once they're out. Once Tomcat 9 goes final, you can immediately take existing Spring applications and upgrade them. In Spring Framework 5.1, there will be a little bit of dedicated support. We will allow for programmatic pushes, for example, in a convenient way, the way you expect it to trigger in a Spring handler method. So that's a little bit we're going to do, but it's not actually that critical. That's a bonus. Upgrade right now, and Servlet 4 will come our way at some point. It'll be nice, but it's not actually as important as you may think it is, the Servlet 4 spec. All right, the functional theme. This is actually a broad topic, and I can only really give you some sneak peek into what we're doing there. There are many ways of getting functional elements into your code base, and I'm sure you're aware of what you can do with collection streams, or at least you've read up on it, right? This is slowly creeping into our code bases. This is not something where we are radically revisiting the entire code at a certain point of time. It kind of slowly makes its way into several parts of our APIs, and that's the same. The same is true for the Spring Framework codebase, for the Spring Framework APIs. This is slowly creeping in, but it is actually creeping in Spring Framework 5 now, because we're JDK 8 baseline, and we can do much more internally, in particular. We can also expose a little bit more than before. So the focus in Spring Framework 5 is a little bit technically driven by the presence of JDK 8 as a required foundation. We can expose Java util function APIs, we can use Java util stream, we can expose optional, we can expose completable future in hard-coded APIs. You might not actually care that much for this, because this is primarily an improvement for us. Spring already has a strong Java 8 support story for application code. So if your code declares Java util optionals, if your code uses collection streams, if your code returns a completable future from an async method, Spring already knows how to translate this reflectively. But we cannot use those API artifacts in our contracts, in the fixed compiled contracts. We can only reflectively support them in your code. So to some degree, some of those improvements are for us. But let's focus on what shines through to the application. And this is primarily about the registration of bean definitions and the registration of processing endpoints, like web endpoints, messaging endpoints. In Spring 4.3, we already have a very rich annotation story, a really comprehensive annotation-based component model, down to many little refinements in the corners. We have a very established endpoint style, request mapping methods, message mapping methods, a very consistent endpoint arrangement, self-describing annotated endpoint classes. What we're exploring in Spring 5 is a different style of setting up an application, of registering beans. We are trying to take it from where we are, so they're going to be variants of the annotation-based model, bringing kind of the reactive facilities in, for example. But there's also a fresh, different cut, programmatic setup in a functional style where there are no annotations at all. And Kotlin sneaks in here, as we're going to see in just a bit. So just to give you an idea of where we're going here. This is what you can do right now in Spring Framework 5 OM4. If you're setting up an application context, you can register beans using suppliers. You don't have to specify a supplier, which is kind of a creation callback, a Java 8 supplier. But if you're happy with the default constructor, register foo.class. If you want a bar.class bean of yours to be created through a custom factory code, you could do an add_bean method in a configuration class, as established in Spring, but you could also register it like this, with a supplier, a lambda expression or a method reference that creates a bar instance. This is the only thing it takes to register a component with a convention-based name, a particular class, and a supplier callback in this model. Programmatic bean definitions aren't anything new in Spring. You could always do them with, you build a bean definition object, set bean classes, apply properties. It's a little bit extensive in terms of code. What we're exploring here is sweet, concise, down to one-liners, callbacks with suppliers, where you can conveniently register 20, 30, 40 classes as well if necessary, and it's still not overdoing the structure of your setup code. So there are different variants here, right? If you look at the variant below, you can see that there is a version where you can pass in a bean definition customizer, this is this set lazy init call, light inline expressions allowing you to configure the details of the bean definition that is being registered. So you can actually see the connection to the underlying programmatic bean definition API. The variant with the foo class here is also quite sweet. We can register a callback to the constructor, the default constructor of the foo class with a method reference foo new. This is almost equivalent to what you're seeing above, right? You can just skip it. But there is an important difference, or a sweet difference. We don't have to use reflection if you provide a supplier. This setup model is at this level completely free from any reflection. There's no annotations involved. There's no reflective dispatching involved. Because if we have a supplier, this is a programmatic callback that the JVM compiles in a very efficient way without using reflection for us. And we just trigger it when we need a new instance of that bean. So there are some really sweet benefits to this particular model that we're exploring here. In a Kotlin world, the same code in Kotlin, and we're not going to turn this into a Kotlin talk, but just compare the examples. It is basically the same code in idiomatic Kotlin style, setting up a generic application context. This is basically the Java-like Kotlin style above. You might notice a few sweet differences, like you don't have to repeat the bar.class class in the register bean bar line, because lambda expressions or expressions in Kotlin actually do retain their return type, which is not the case for Java 8 lambdas. So we don't have to explicitly specify the bean of the class of the bean that we're creating here, the type of the bean to use for matching purposes. We don't have to, but we can infer it from the Kotlin callback. But otherwise, it serves the exact same purpose. The code below is even more interesting. This is what we call the Gradle-style usage of Kotlin. Gradle 3 has a Kotlin usage model as well, and a little bit along the lines of Gradle's established style with Groovy. This is a sort of inline setup of a class here, calling callbacks of this class and using an inline type declaration structure instead of class arguments. This all naturally comes with the way that we are doing this in Spring Framework 5. Just general supplier callback-based method structures, perfectly Java 8 ready. A couple of Kotlin extensions that we're shipping in our jar files, KT files, that are picked up by the Kotlin compiler automatically, so that some of this sweetness can be done just by using the standard Spring jars with Kotlin. It just very naturally comes through using the combination of Spring and Kotlin in your application setup. It's very, very convenient. No explicit setup necessary. All right, so this is the functional theme that we're exploring. Let's go into reactive for the remainder of this talk. It's actually connected, right? As we're going to see in just a moment. You might have seen some reactive talks before. Maybe a reactive talk yesterday morning. So the reactive manifesto specifies a couple of characteristics that we intend to achieve in a reactive processing architecture, in a reactive application architecture. And this is worth a talk in its own rights. It's without debate that we intend to improve the responsiveness of our systems, the resiliency of our systems, that they can actually behave properly, as good as they can, even under non-ordinary conditions, right? If there is anything going wrong, a part of the system not working anymore, let's keep the rest of the system working to the best possible degree. Those are all very important qualities of our systems. We don't necessarily have to redo the entire application infrastructure to achieve them. But if we want to take the possibilities, the processing power of our hardware to the best possible level, if we want to scale it up to an almost unlimited number of clients beyond the capabilities of a JVM thread pool, then reactive processing architectures have a really sweet spot. What we're doing in Spring 5 is that we're exploring reactive processing architectures in parallel to traditional servlet stacks, as we're going to see in just a moment. We have a project in our vicinity, also Pivotal sponsored, called Project Reactor, recently having had its Reactor 3 GA release late last year. This is the foundation that we're using for the Spring 5 reactive stacks as well. Reactor is essentially a kind of modern-day tightened version of RxJava, simply speaking, right? It's a reactive processing kernel based on the reactive stream specification. It supports a standardized back pressure-driven arrangement between publishers and subscribers interacting with each other at runtime, only really being called back once the corresponding streams are capable of delivering a further element or processing a further element. So it basically takes an arrangement of publishers and subscribers and very efficiently calls them back from an event loop, very minimal uses of threads, with a very small number of threads, and just making sure that almost an unlimited number of publishers and subscribers can work at the same time. Nothing's ever unlimited, but the difference is that a JVM can, a servlet container on a JVM with a request thread pool, an HTTP endpoint thread pool, can only really scale up to a certain number of threads. That's basically the number of client requests that you can handle concurrently. Whereas in a reactive processing architecture, that's not actually connected. The number of clients and the number of processing threads is completely independent. A very small number of threads may handle a very large number of client requests at the same time, even if some of those client requests are waiting on third-party systems to slowly deliver their data. We don't have to block, to wait on an external system. We just basically pause and let the reactive runtime call us back once some further data comes in from the third-party system. Very, very efficient uses of threads on the JVM, and therefore very efficient scaling. How are we going about this from a Spring application architecture perspective? We have the stack on the left as our traditional, actually very common and still very first-class web stack in Spring. This is basically a servlet container, can be a standalone Tomcat, JD, JBoss, like Wildfly, whatever installation. Or it can be an embedded container, like in Spring Boot, an embedded Tomcat, embedded JD, embedded Undertow. We're using the Servlet API on top very explicitly. It does shine through to Spring Web MVC. There's Spring MVC on the Spring MVC programming model on top. These days, primarily the annotation-based model, controllers, request mapping methods, controller classes, request mapping methods. If you choose to expose an HTTP servlet request in your request mapping method, that's possible. That's out-of-the-box supported in Spring MVC. You can interact with the Servlet API. It is a Servlet API-based web framework, essentially. This is the stack that we have right now, and this is the stack that keeps being there in Spring Framework 5 as one of the two web stack options that we're shipping. In parallel to this, we are introducing a new reactive processing stack. Reactive streams based. So reactive streams, by the way, is an external specification, lives on reactivestreams.org. It's being brought into JDK 9 as Java Util Concurrent Flow. It's the same specification, the same API types. So just if you're interested in the underlying nuts and bolts of how those pieces interact, check out reactivestreams.org. So this is very central to our stack here. There is no Servlet API involved. There might be a little bit of Servlet API involved in the container adaptation code underneath, but it does not shine through. The HTTP abstraction, the reactive HTTP abstraction, reactive streams-based and using Project Reactor, is the foundation for what we're calling the Spring WebFlux framework, which is basically Spring MVC on a reactive processing stack. But with different trade-offs, different characteristics. Certain things you cannot do anymore, like render JSPs, and certain things you all of a sudden can do in very efficient ways that you can never do in Spring MVC. On top of this, there can be the same programming model or a similarly minded, similarly structured programming model, controller classes and request mapping methods, as I'm going to show you an example in just a bit, as we're going to see. There's also a different way of consuming the reactive processing stack in Spring 5 through the use of what we call router functions. So, two parallel web stacks, basically two options. They are well integrated and well aligned, but they are essentially separate stacks. Distinct qualities in each stack. It's your choice whether you're going to use one or the other for any particular application, for any particular service, like in a microservice architecture. This is a decision that we leave up to the system architect, to the applications architect. All right, so what does this look like? This is a reactive web controller. I mean, initially, you might not even notice, right? You need to look almost a little bit closer, because it's a controller class. It has mapping methods, handler methods with mapping annotations. Looks almost the same as it always does. But look at the signatures down here. This is a sketch, right? An example for what you will typically do. A reactive controller manages a particular HTTP endpoint in this kind of architecture, and it typically reaches a request through to some processing level below, like a reactive repository implementation. So there's intentionally it's very light on code here. It calls a repository that we're not seeing here, but the repository obviously returns here a type called mono from getUser and a type called flux from getUsers. And we can reach those somewhat strange types through to the processing stack. So the reactive dispatcher in Spring 5 naturally understands those. Now, what is mono and flux? Those are project reactor types, the two types in project reactor that really matter from an application's perspective. They are reactive composition types, composition pipelines. If you are aware of RxJava, flux is basically RxJava observable. And mono is essentially RxJava's single and completable combined. You could actually expose RxJava here. The Spring 5 reactive stack naturally understands RxJava 1 and RxJava 2 composition types. So if you have a repository implementation using the couch-based driver, which is RxJava 1 based, and returns observables, just return the observable through from here, and the Spring 5 processing stack naturally adapts to the observable that you are giving it. So the idea here is that what we are returning from such a handler method is a processing pipeline. We haven't actually read this user by ID yet. We haven't tried to find all users yet. We just built the processing chain where all steps that are necessary to find those user objects have been built up, and as a kind of, it's ready for processing but not triggered yet. In a reactive streams-based architecture, we only start processing once a subscriber actually registers and once a subscriber actually is able to consume them. So the moment that you return this processing chain to the reactive web stack interacts with the subscriber, which is basically the response for the incoming HTTP request. And if we are able to push data back to the client, the next chunk of data back, then we're triggering the next step in that mono or flux in order to get the data from the underlying repository to shovel it through, including all adaptation steps necessary. This is a very efficient processing architecture. It effectively means that your handler methods don't actually block. When a handler method is being invoked, it's almost a notification. Here's a request for this particular binding, for this particular mapping. Give me a processing chain for this request. That's what you're doing, wasting a few CPU cycles to build that chain, and you're returning it. But you're not actually blocking. You're not waiting on an external system. You're not retrieving any actual data. That's what you leave up to be triggered from the reactive web stack once it's ready. Right, this is the annotation-based variant. Now, what's a router function? A router function is another way of consuming the reactive web stack. Quite different initially, not that different if you look a little bit more closely. Basically, forget about annotation-based endpoints. It's a reactive web processing stack based on Project Reactor. You can build what we call here delegate methods, but those are essentially handler methods, just not annotated, being compatible with the handler function callback interface. So there's router functions and handler functions. A handler function takes a request and returns a response. It has a fixed signature, so that you can use it as a Java 8 method reference or a Java 8 Lambda expression. And within each such method, what you're doing is you're basically programmatically taking the request, and you're trying to find out what to do. In this particular case, we extract the path variable called ID, convert it to a long, pass it to the findById method in the repository, and we are building a servlet response with a particular status, if actually ready, right? That's just a suggested status. And we pass this processing chain, this user processing chain, into the response. We are basically doing everything we can in terms of instructions of how to process this request and how to come up with a response. And we return it. This is the same job that an annotated handler method returning a monorail flux has. Just a different style, entirely programmatic. The same for the get users variant, right? Basically, it's a little bit simpler there because we don't have incoming parameters. A router function up there, a router function now just says like, instead of annotation-based request mappings, we're saying for an incoming request of this kind with this predicate, bind it to that handler method. We have an instance of this delegate class somewhere, and we use Java 8 method references to bind them to particular methods. This is a programmatic way of expressing basically request mapping predicates to particular delegate methods. In all of this, there are no annotations involved in this style. There is no reflection involved. This is using Java 8 Lambda expressions, Java 8 method references, programmatic callbacks. We are not actually reflectively dispatching anywhere. Now, a variant of the same example with Lambda expressions. So this is basically exactly the same, just instead of pointing to a delegate method, we're using the same router function setup, and we are using an inline lambda in order to express the handler function. So it's the exact same code, but maybe it's a little bit more appealing if you're used to lambdas already. The nice point of delegate methods is, of course, that it scales very nicely. I mean, scale this up to 10, 15 routes, each one line, 15 delegate methods, can be a very nice programmatic arrangement. Whereas if you're scaling this up too far, you have plenty of inline lambda expressions. So this is only really useful up until a certain number of routes, a certain complexity of handler functions. All right. So this is essentially the gist of what we're doing in Spring Framework 5.0, with a little bit of 5.1 in there. Let me wrap up with where we are and when we're going to ship it in all applicable brevity. Spring Framework 5.0 is scheduled for a release candidate 1 in April, very soon now, and ships everything that we can technically ship right now. JDK 8 Plus baseline across the framework, the functional style registration APIs that I've been showing, and the entire reactive story. This is all going to happen in Spring Framework 5.0 already, GA likely around May, right? But RC1 in late March or early April. There's a few further initiatives of ours. A sister project of ours, Spring Data K, already has a reactive repository model in the works for the data stores that it supports. So largely NoSQL data stores like Redis and Co. The Spring Data K release train also intends to have a release candidate in April. It's very soon now. Another important piece of the puzzle, reactive repository interaction with third-party data stores. We have Spring Boot 2.0 in the works, which is going to be based on Spring Framework 5 and on Spring Data K. This is going to have a milestone in April, at least. At the moment, you can already use Spring Boot reactive starters with Spring Framework 5, but they are Spring Boot 1.5 starters. So a Spring Boot 2.0 release that's fully integrated with Spring Framework 5 and Spring Data K is going to come very soon now as well. And this is where Spring Framework 5.1 will wrap it up towards the end of the year. We intend to have a next feature iteration towards the end of this year where we are picking up the things that we only can pick up at that point of time. Servlet 4.0, hopefully final by then. Bean validation 2.0, the JSON binding specification with out-of-the-box support on our end. JDK 9 GA support with added value that we can provide beyond the compatibility story that we have already. We intend to let the framework build on JDK 9 out of the box so that it's our standard build JDK at that point, and maybe expose a few nice API variants wherever that makes sense. And Spring Framework 5.1 is also going to be the foundation for the Boot 2.0 GA release that's coming around the same time. So as you can see, there's a lot coming from our side this year. It's all part of one large comprehensive story with a couple of themes, JDK 9, HTTP2 enabling, well, a functional style allowing at least for a different style of composing your application, and a strong reactive story with all pieces necessary in order to build a Spring-based reactive processing architecture. It's the reactive web endpoint model in Spring Framework 5. It's the reactive repository model in Spring Data K. There's actually reactive support in Spring Integration and in Spring Security and in other Spring-related projects as well, fully enabling a first-class reactive model, basically towards the end of 2017. All those pieces will have come together the way we intend them to, in parallel to a very modern, very efficient, even then Servlet 4 compatible, servlet-based web stack. Two first-class options that we're providing to you in order to make your choice for modern-day Spring Web architectures. All right, well, so much for everything I had in this talk. I've got a Q&A session this afternoon, like 15:35, an Ask the Architect session. You can look it up in the schedule. If you want to have some discussion around this, I'm happy to take it like right now here at the stage or this afternoon in the Ask the Architect session. Thank you for your attention, and enjoy the rest of the show.